Okay, this is a hopefully fun talk, but also a bit of a work in progress as it's a different audience than I'm used to. So at least a mix of some people I'm used to, but in much more density. So I'm trying to explain how to approach post-training for AI applications. And the first slide is a PSA that model training is extremely hard and very expensive, and you probably don't want to be doing it. So this is kind of a self-indulgent talk. So you could get hooked and be stuck doing it and spend a lot of money. It is very cool, but I added this at the bottom is like being very good at using models for your application and knowing what is out there is probably going to deliver more value, especially as this changes very quickly. But if you want to do this, you really need to think about two things. It's just like, what can you actually change with the models and what tasks do you care about? And then there's going to be a small overlap there, and that's where you're going to spend all of your time. And most of what I do is focusing on methods and releasing tools in the open, which are multiple cycles before they will reach many applications. So someone will take a model and then add more data to it to actually reach an application. But a lot of these things are just fundamentals of how models are being trained today. So where post-training starts is you take some raw base language model. Base language models are very fun to play with, mostly because they are very weird. And what we do is we take this raw model trained on the internet and we come up with a set of tasks we care about. We think about human preferences. We have a set of core skills. And this is where instruction following actually comes in. And initially, approaches to post-training were things like InstructGPT, learning to summarize from human feedback. Original Claude, original ChatGPT were trained with methods like this, where you take this base model, you do supervised fine-tuning, also called instruction tuning, on a bunch of human data, then you train a reward model, and you do some fancy RL or other optimization, and you get a final model out. I suspect I've already lost some people, but this is roughly what you're in for. And I don't go into all the math of all these things, but mostly like instruction tuning is the same loss function used to train language models with very specific data sets with our prompt completion, like tell me about the Roman Empire, or very benign things like this. And then you collect human preferences, which are comparing two responses to a piece of text. This is largely doable today if you want to approach it. I think it doesn't address a lot of the things in this room, or a lot of things that people in this room should care about. It was mostly focused on improving alignment to like A/B testing and chat testing, and targeting specific capabilities has become more of an interest in language models as we need to figure out what to use them for. So today this looks a lot more complicated. You don't need to know all the details. I can point you to the tutorial I gave this morning if you want to know more about this. But if you look at the papers like Meta's Llama and things like this, the few glimpses kind of behind the mirror that we get, there's a ton going on that they use to train these instruction models. And really, you can put a ballpark on the price that Meta pays to do this full post-training on many tasks and many skills to be over $10 million and could even approach $100 million for these really large projects that they have planned. So we did this at AI2. It was like a team of 20 people, order of magnitude less spend, especially when we remove some data costs. But it is a very big thing, and it is a lot of moving parts on these systems. So to kind of go back to here, I'm just going to use this as a transition diagram. If we look at the model that you get out, this is where I think most people should actually start. You should largely ignore the base models that are there, because doing this preference alignment to human data is going to be a lot of money and work. This is where most of the data budget goes, is for these pairwise comparisons. But there's kind of a really small niche of research where they're fine-tuning from these instruct models. So they take the model that Meta released and they're doing various things to elicit very specific behavior. So there's a lot of different things that you can do, and the list is growing. We've heard about prompt engineering. You could just do instruction tuning on top of these models. OpenAI released RL fine-tuning, which is something that I've been working on related stuff, so that's interesting to me. And there's this whole question of like inference scaling. What does this mean? So really, you can think about post-training for applications as taking a good, strong model that's really good in general, so you don't have to worry about like, is it good at chat? You just want to make it better on math or what the equivalent task to your domain is. Some of the examples that you can find, this is mostly because I'll share the slides and you can go click around and see things that I find cool in the space. There's a group that works at a startup that the grad students used to be at Berkeley. They released these Athene models, which is exactly this. They take llamas-based checkpoints that are instruction tuned already. They come up with some tasks that they care about, and they show that they can do much better on these by continuing to fine tune on what Meta built rather than redoing the whole stack. These tend to be much more data efficient. There's another one I want to mention later, but you can see these trends again and again. There was an academic work that took Google's instruction-tuned open weights models and applied more preference tuning on it, just a few thousand examples, and did much better on Chatbot Arena, this evaluation that everyone talks about right now. There's another one, NVIDIA did this. They took their 20,000 data point help. I think I'm going to mess it up. It's been a long day, but I think it was their help steer data set or something. We can find it. And also outperformed Meta's model on Chatbot Arena. Chatbot Arena is probably not what you care about, but it goes to show that you can kind of do this multiple times. And I think that you're not going to get that much help from academia in the near term. For whatever reason, this isn't really, it's not considered an apples to apples comparison if you're doing a research paper on post-training. On the other side, there are products for fine-tuning. I don't know a lot about them. I should talk to more people that are using these, but largely if you use the OpenAI fine-tuning API, it's doing something like a LoRa, a parameter-efficient fine-tuning in the background, and they are also fine-tuning from instruct models. So it's good to take inspiration from what these closed companies are doing, because they probably know what they're doing for some things, and don't try to reinvent the wheel of redoing the whole research pipeline when you're training these models. So if we go back to this, I'm going to kind of just go through some high-level decisions that I would make if someone were to say, I want to do X, how should I approach it? And it's kind of a list of things that are the decisions to start with, and then you have to figure out all the details from there. So the most important thing is always data and evals. The question is, how much data do you actually need? And my team, we would say that you probably need about 1,000 instruction tuning samples if you're going to use the supervised loss to see behavior change. I liked how OpenAI described it in their RL fine-tuning live stream, where they say that this type of instruction tuning on top of a strong chat model is increasing the prevalence of features. So instruction tuning isn't guaranteed that the questions you put in will be right, but it's going to increase the behaviors that you want to see. That's still useful, especially if you want your model to have a specific feel for your application. But RL fine-tuning is opening a whole new door, which I find very exciting, where OpenAI says you need about 10 training examples. The big thing to think about this is that RL fine-tuning, you're just going over the same data again and again until the model training actually gets better answers. I think we work on code, math, and precise instruction following in our first research project that was really similar to this. Precise instruction following is if I ask you to write a letter, you can specify that every sentence has to start with the letter A. These are verifiable things. You can write reject statements in code to actually summarize these, and this is very similar to what OpenAI is doing, and I think a lot of applications will apply to this, where you have verifiable outcomes that you want. They're pretty simple, but we haven't known how to train models to do it. And if it is more data efficient, that's even better. If you do full post training, kind of repeating this theme of you might not want to do this, you probably are going to use millions of data points at each stage of the post training pipeline. And that's why it's just try starting with instruct. Let me know how it goes. You don't want to be doing this. It took us multiple months with 20 people full time. There's also the question of, now that there are a ton of preference tuning methods, which one should you use? I've been talking a lot about instruction tuning in RL. There's a lot more words you can go into this, and this is generally how I view them. I think that the top and the bottom are going to become increasingly popular as you think about fine-tuning as starting from an instruct model, because this preference tuning is most useful for kind of just really getting strong style and making the models really reliable and getting the outputs to be something that people like. I think what people like is not going to be what shifts the needle in most really specific domains that you're building from. Instruction tuning will get you started, and if this RL tuning becomes a real deal, it is going to be very powerful, because it's just the domain space is very big. There's a lot more here. I think you may have heard about this like direct preference optimization algorithm, and if you should use DPO or PPO or all the million other papers that have come out in the space. It really made great memes for people that are nerds about post-training. Largely, this is from last year, and all the things that I've linked here are from last fall. The situation hasn't changed a ton. If you want to do preference tuning, this DPO, direct preference optimization, is just so much easier to implement that it's where you want to start. But if you're getting into this picture, you're probably in too deep, because it's not going to be more than like a 1% difference on any performance, and it'll be a whole headache. A more interesting question is there are specific algorithms that have been designed that can use different types of data. The standard preference tuning is a chosen and rejected pairwise sample, but this KTO algorithm essentially takes data that is like a thumbs up. So if you have a chat endpoint where a user can say that response was good, this preference tuning algorithm is designed to use this type of data. And I've heard from people that have switched from trying to do DPO or these kind of more complicated setups where they had to come up with a data rule to create new data. And they're like, this suits my endpoint better and what the users are actually seeing. And it actually worked. So I would say keep an eye on the space and just kind of don't try to force things, and see if there are people coming up with new things that are better suited to your application. If you are actually doing this, one of the biggest questions is which model do you start from? While you'll see companies say that their model is the best, and the academic evaluations are very obvious that like Llama 3.3, the newest model, looks great, it beats everything. When your domain is not something that these academic benchmarks are doing, you'll have way higher variance in performance. Something that we do at AI2 is we have both like development and unseen evaluations, where when we're training the model, we're trying to get the best scores on these development sets that you can. But we have unseen evaluations that are similar to kind of test the generalization of the models, and it's really hard to get the models to generalize in this way. So it's very much of like you get data for a specific thing, you make the model better at it, and you kind of repeat this process. But all these kind of long tail tasks and building your own evaluations is not going to be in the core training regime for most of these models that you're going to try. So it's very important to just like try a bunch of them. Even worse models may do better when they're worse on standard benchmarks. This is on performance. If you're doing open source infrastructure, there's also variance on just raw like performance or like computational efficiency, bugginess, etc. I think so. My friends in the back were trying to use I think a Phi model, 3 billion parameters for some data processing, and it turned out that its VLM implementation was slower than the Quen 7b model. And it's like, okay, like you should just try things and don't assume that everything works exactly as it should. And there's a lot of variation here. Prompting, again, is one of the things that is kind of not necessarily neglected, but the academic community doesn't welcome it as much, even though it is extremely powerful in changing the behaviors of the models, and it's very cheap. I would say that you should start with this, even though I don't have general recommendations for how to do it. I'm guessing being very detailed helps, and then build evaluations where you can test it. And so generally, you want to start with the things that are easiest and build from there. Another question that is fun to get, because it's new, is how can I use inference scaling laws? The one thing that you need to think about when you're seeing these plots in any inference time compute is that a lot of it is not going to make the model solve tasks it couldn't do at all. So if your model gets 0% on a task, spending more on inference is not going to help it. But if it gets a low probability correct answer, what is essentially happening is that a lot of these inference methods are making it so you can do like a more robust search. So if you do 10 times the compute, you can get the one correct answer, the answer out that would have been correct that one time. And there are going to be more improvements here where the actual underlying abilities improve, but you can a lot of the research is built on this idea of just sampling more. I think this plot is from a paper that I think argues that most of these papers are going in the wrong direction and just running more samples from the same model is what you need to do. So a lot of it is you're gonna hear a lot of hype about this, but your model needs to be able to correct answers correctly for some of the models in order to improve. And that's gonna be the same for the OpenAI RL API. If their models can't do it at all, they're not gonna get any learning signal to improve, so it's just not gonna do anything. That's where I'm gonna switch onto my opinions on this, which I find exciting, and just kind of, we'll see in a few months how this ages when the public version comes out. It's like still a beta program, but I think this could be a big deal for how fine-tuning and just applications could be approached. If you don't know, essentially what they said is that you can upload data where you have a question and an answer. The answer needs to be able to be something that can be verified as right, and they provide graders. And what they're doing is they're running reinforcement learning behind the scenes to prompt their models to complete a bunch of times, and they check the completions versus your answer. And then if the answer is right, it rewards the model and changes the parameters in order to actually do this more often. And they do multiple passes over the data to actually make the model change its behavior. So if we went back to the instruction tuning example in the beginning, it's talking about changing the features that occur in the model, where this could really change how it gets to a solution. And I've seen this in training models, and it does seem like a big open door for post-training at a raw research level, and then we'll see how long it takes to trickle down into applications. So this is the data format that they use that I was mentioning. This is from the blog post. They show this probably more complicated than it needs to be example from biology, where the correct answer is, I don't even know what this is. It's some gene sequence. The simplest examples are math. It's like you could ask a grade school math problem, which is like, Bob has 6 apples. He gives 4 to Mary, who gives 2 of hers to someone else. Like, how many apples does Mary have? Like, that's a much more logical way to see this, is with math, because we can kind of reason through it ourselves and see if the model is improving. But OpenAI gave a complicated example, which we'll see to the extent that hard things work. We have some data on Hugging Face that looks like this as well, which is essentially a prompt, a ground truth answer, and we just have a bunch of them. That's how we trained some of our models at AI2 to get better at instruction following and math. So it's fun that there are some open examples that you can look at and not do all of just like trust us like they do sometimes. And then what happens is OpenAI made a big deal about their graders, which are language models for extracting answers. Here's an example on the right. Is like, if you're doing a math problem, you can express a math answer in a lot of different ways in text. And largely, when you open this up to many more domains, you're going to need some level of intelligence to reliably get these answers out. And they're opening this up to anyone, which is why they have this whole what will be graders documentation in different ways of extracting answers and different ways of scoring answers. But in reality, it's just, you can think of it as a box that's like yes or no, is this right? They have all this fancy UI, which is tracking runs, like what the actual performance is on your task. So top at 1 or top at 5 means like, what is the score if you sample 1 time from the model or 5 times from the model? And we'll see how they put this together. I think UX for training is something that I haven't thought about as much. It's mostly to consumers, but I hope that this is easy to use. Here's more stuff. I don't need to do free PR from them. This is what the learning curve will look like. I'm going to switch to ones that we have just to give this as a primer. You train longer on the x-axis and your numbers go up for your training data. This is what you want to see. We did this for multiple evaluations at AI2 with our open source code, and we did GSM-8K is a popular, easier math eval. Math is a harder eval. IF eval is the instruction following that I was describing. And what we do is we have separate training data from the evaluation. So the test set is this first column is the actual evaluation performance. So that going up is generalization. And the second column is the training data. And the third and fourth are just RL, internal data to training. So you can see that all of these, the training set gets better, and only some of them have clear generalization. I think when you do this in your case, you want to have your trained data really closely match the evals. We were targeting specific skills that we're trying to map from different types of data. But the real thing is, like, to some extent, these behaviors already exist in kind of what OpenAI was showing. And the feedback loop to do this looks something like RLHF. It's really a standard RL loop, but you do this on top of a language model. If you look at more literature on reinforcement learning, which is like trial and error learning, you'll see a lot of things like this. So you can try it here or reach out if you have questions for code. If you want to plug this into something, we'd be interested to see what you get. One of the fun things is while O1 models are new, I don't really use them for anything other than like a Hail Mary on writing code. If OpenAI does aggregate data from people using the fine-tuning service, it could make it so these generalized reasoning models are much more useful in a lot of domains, which could build a lot of value. So it's one of those wait and sees, but I see why they want to do this. They want to get more data to kind of expand the scope of O1 models to more tasks for more users rather than what is now just like a reasoning in code toy. If they really get more domains, it could be very important to them. So some concluding advice, to repeat things like I said. Data is the most important thing. Look at your data. Everyone says this. This wasn't really a data talk, but if I don't put it in, I am making a mistake. You need your own evaluations. This is kind of covering your bases. Don't trust academic evals. You need to build your own evals, especially when new training regimes are requiring it. So if RL tuning requires evals, you're going to need to build them to actually do the training, which is probably helping people along the way. You should start from fine-tuning from instruct models. Base models are going to be more work than it is worth, and we've seen a lot of cases where this can work really well. I've just talked about RL fine-tuning, so it'll open up a lot of domains where this actually matters. But most people, I think, will start with supervised fine-tuning or instruction tuning because it is what we know. A lot of infrastructure is designed for it, and so on. Okay, this is kind of a summary. To repeat myself the last time, preference tuning is probably not worth it. Human data is hard to collect, and there's a lot of noise, not a ton of literature on how to do it. So I'll leave this up for a second and then kind of say thanks to a lot of people that contribute to post-training and other efforts at AI2, and hopefully this was interesting and saved you a potential rabbit hole that you didn't need to go down.